Hi again, everyone. It's Dave Giles here for the fifth lesson on Unit 2 Thermal Physics for Cambridge International Education, IGCSE Physics. This lesson is on heat, temperature, and using the Kelvin scale. So the learning objective for today is describe the relationship between heat and temperature and convert from Celsius to Kelvin. So first of all, we have to have a look at what temperature actually is. So temperature is the average movement energy. Now, the term for movement energy we use is kinetic energy of particles. So hot gases have more, and we feel a higher temperature with hot gases. You can see the hotter gases from the picture down the right are moving faster. So I've got two gases here. And first up, we're going to look at gas A, which is the hot one, and gas B, which is the cool one. Now, you'll notice that gas A has got less particles, and if you add them up, you get a total energy of 15 joules, with an average, therefore, of 5 joules, because there are, according to that, there are 3 particles. The second one's got a lot more particles, and the total energy of the cold particles is more, but it's hotter, so it's colder, because the average energy is less. The average is only about 3.5 joules for the second set. So 2 little scenarios here to think about for a moment. The first one, which has the most thermal energy? We've got 2 choices, either a boiling kettle or a cold swimming pool. Now, naturally, you might think that kettle's going to have a lot more thermal energy, because if it's boiling, it's going to be close to 100 degrees Celsius. So, of course, that's going to have the most thermal energy. But that's not quite the whole story. Even though the swimming pool itself is cold, a swimming pool could hold thousands of liters of water, whereas a kettle may be around 1 liter. So there's a lot more particles. So the answer is the swimming pool, because it's got low energy particles. However, the large amount of water particles, so they've got a larger total energy. The kettle has high energy particles, however, only contains a small amount of water particles, so the total energy is quite low. Scenario 2 here, we've got Jenny and her birthday cake. So on her birthday cake, Jenny has a cake with sparklers on. One of the sparklers hits Jenny. The temperature of the spark is 1200 degrees Celsius. Why doesn't she receive serious burns? And the first point I make is it's a very high temperature spark. Well, the reason for it is, even though it's high temperature, there's not that many sparks. Okay, so there might only be a few particles in total that actually hit Jenny. So although the average energy of the particles is very high, the total energy is actually relatively low. There's also the fact that in the short distance that travels from the cake to Jenny, the spark will lose some energy and therefore have a reduction in temperature. Okay, so the next thing to look at is the Kelvin scale. So up to now, you've probably only looked at temperature in degrees Celsius. At IGCSE and at A level and above, we generally in physics use something called the Kelvin scale. So the SI unit for temperature is actually the Kelvin. So that's the standard unit for temperature is the Kelvin, not degrees Celsius. It's a better scale for use in space where there is no water. Now, Kelvin begins at a temperature called absolute zero, and there are no minus numbers. So, as you know, 10 degrees in Celsius, you can go into the negative figures. You do not have that with the Kelvin scale. At 0 Kelvin, almost all matter is solid, and and the vibrations of the particles are incredibly small, and all the particles in a substance stop moving. They have no energy left to lose, so the substance cannot get any colder. Hence, it's called absolute zero because there is no lower it can possibly get. So absolute zero is approximately minus 273 degrees Celsius, which is 0 Kelvin. So in the Celsius scale, it's calibrated based on the melting and boiling point of water. So as you already know, at 0 degrees Celsius, pure ice melts. The Kelvin scale, on the other hand, is calibrated based on the lowest possible temperature, and that is 0 Kelvin, where particles stop moving. The Celsius scales can have positive and negative values, whereas the Kelvin scale is always positive. And 0 Kelvin, we mentioned about a moment ago, is called absolute zero. So to convert from Kelvin to Celsius, or from Celsius to Kelvin rather, you take your temperature in degrees Celsius and add 273 to it. So 0 Kelvin, for example, would be would be negative 273 degrees. So here's the conversion. So if we're going from Kelvin to Celsius, you subtract 273. If you're going from Celsius to Kelvin, you add 273. So if we look at here, absolute zero, 0 Kelvin. The melting point of ice is 0 degrees Celsius. That's 273 Kelvin, whereas it boils at 100 degrees Celsius, which is 373 Kelvin. Okay, so here are two very quick past paper questions on converting from Kelvin to Celsius. Give you a moment to think about it. Okay, so the first one there, this is from June of 2024. How is temperature in degrees Celsius converted to a temperature in Kelvin? So you just add 273 degrees to the temperature in degrees Celsius. So the answer is A. Copper has a melting point of 1,100 degrees Celsius. What is its melting point in Kelvin? So remember, to convert from degrees Celsius to Kelvin, you add on 273. So it's 1100, add 273, which gives me 1,373 Kelvin. Okay, so this was quite a short lesson. Please follow for the next lesson, which will be a little bit more detail, which is looking at specific heat capacity, and I will post a link down below. Thank you very much, everyone. I'll see you soon.